Step by step, ooh baby, gonna get to you, girl. Today we're talking about step functions. A step function is a function of yours when your mom remarries some guy. Just kidding. This is actually what a step function is. See how they look like steps? Well, that's what a step function is, and it's kind of very unique. I mean, let's take a look at, let's make believe at what happens if I say that x is 1.5. Well, when x is 1.5, y is -2. How about when x is 1.9? When x is 1.9, y is -2. What about when x is 1.1? Well, when x is 1.1, y is -2. So basically, it seems that whatever decimal value 1 is, it just rounds up to 2. And that is what a step function does. Unless the number is itself, in which case it becomes itself. So a step function takes a number and either rounds it up, or in a case that's not seen here, rounds it down. And in no matter what case, it's going to keep that integer itself. So that's what step functions do. Now, as far as that whole rounding up, rounding down talk, let's actually talk about that. Now, we have two types of functions. We have a ceiling function or a floor function. A ceiling function look like this. See how these kind of look like absolute values but have these little marks that kind of curve in where a ceiling would be? That is a ceiling function. What a ceiling function does is it either keeps the integer exactly the same or it rounds up the decimal no matter what. So in this case, 3.14, if I plug in 3.14 into this guy right here, I get the ceiling of 3.14, which rounds up to 4. I know we want to round down, but that doesn't matter here. The whole 5 or above stuff no longer exists. Not with these guys. So it could be 3.1, it could be 3.9. Either way, if it's the ceiling function, it rounds up to 4. The floor function rounds down no matter what. Okay, so in this case, the floor of 2.7 is going to round down to 2. So in a case like this guy back here, this was the ceiling function because it took any number and rounded it. Actually, no, it's the negative of a function. Let's not even get into that. Let's just pretend that never happened. There we go. So let's actually do a few problems. Here's A. A is saying, let's take 1.2, plug that into x, all right, 1.2, add 0.5, and then take the floor of it. So I get 1.7, and the floor of 1.7 is 1 because we round down. Let's do B. B says, let's take 1.7, plug it into my x there, add 0.5, which gives me 2.2, and round that down no matter what. All right, my computer decided to die out on me, so I had to restart, and here I am again, picking up where I left off. There are two ways that you can graph step functions, or at least two ways that they could possibly look like, and here's one of them. Basically, it looks like a piecewise function, but when graphed, it's going to look like steps. Not exactly the same perfect one block each time, but still steps. So I have just the first quadrant because I'm only going to be graphing in the first quadrant. So what this is telling me to do is to go between 0 and 2, but not include 0, but include 2 and graph at 4, which is just a horizontal line. So 4 between 0 and 2, but include 2. Bada bing. Baymax! Looks like Baymax eyes. This is going to be a wider Baymax eyes, but he's going to be taller. I'm going to go between 2 and 5, but not include 2. I'm going to go to 8, go to 5, and include 5. And then the next one, and the last one, is going to be at 12, between 5, but not including it, and 8, but including it. So here's my 5. Allow me to go up to 12 way up here. I'm going to fill that in. Well, I'm going to draw a circle, but not fill it in. I'm going to go out to 8. Could have done a better job at that, but there you have it. Steps. Steps. Step by step. Here's the other way that I can graph this. Let me shrink my head. Yeah, that works. Moving me up there works. Pretty much what this is saying is horizontal line at 4, in between 0 and 1, don't include 0. Horizontal line at 5, between 1 and 2. Horizontal line at 6, between 2 and 3. So this is going up 1 block steps, but kind of starting at 4. So it's like I'm starting at the 4th floor, and I'm not including... so this is like rounding up. This is like a ceiling function. No, it's actually like a floor function. Yes. So let me just draw it all in purple. I haven't used purple today. I'm going to go to 4 up here between 0 and 1, but don't include 0. Then up to 5 between 1 and 2, but don't include 1. Between 2 and 3, between 3 and 4, between 4 and 5, between 5 and 6 at 9. Okay, and those are step functions. So piecewise functions with a twist. That was fun. A lot of fun. Bye.